Imagine witnessing two massive space rocks, one with its own mini-moon, zoom past Earth in a cosmic dance just millions of miles away. Meanwhile, a spacecraft that's been traveling through space for over 4 decades suddenly starts sending back data from the farthest reaches of our solar system after a mysterious glitch and sends astonishing data. These are the incredible real-life events captured by NASA's relentless exploration efforts. Stay tuned as we dive into the fascinating details of these recent discoveries and what they mean for our understanding of the universe. In an exciting development from the cosmos, scientists at NASA's Jet Propulsion Laboratory, JPL, in Southern California, recently captured detailed images of 2 asteroids as they made close flybys of Earth. These images, taken during a brief window of observation, provide critical data that could enhance our understanding of near-Earth objects and refine planetary defense techniques. One of the asteroids, a newly discovered object that was first detected just 13 days before its closest approach to Earth, revealed an intriguing surprise: a small moon orbiting it. This discovery adds another layer of complexity to our understanding of asteroids, especially those with companion moons, which are relatively rare in our solar system. The second asteroid, on the other hand, was a more familiar visitor, having been previously identified and tracked by astronomers. NASA emphasized the significance of these observations, stating, "There was no risk of either near-Earth object impacting our planet, but the radar observations taken during these 2 close approaches will provide valuable practice for planetary defense. The data gathered will offer insights into their sizes, orbits, rotation, surface details, and clues as to their composition and formation." The first of these celestial visitors, asteroid 2011 UL21, passed Earth on June 27th at a distance of approximately 4.1 million miles, 6.6 million kilometers, which is about 17 times the distance between the Moon and Earth. Discovered by the NASA-funded Catalina Sky Survey in 2011, this nearly mile-wide, 1.5-kilometer-wide asteroid has been classified as potentially hazardous. However, detailed calculations indicate that it poses no immediate threat to our planet. Utilizing the Deep Space Network's 230-foot-wide, 70-meter Goldstone Solar System radar, scientists transmitted radio waves to the asteroid, revealing that it is roughly spherical in shape and accompanied by a smaller asteroid, or moonlet, orbiting at a distance of about 1.9 miles, 3 kilometers. Just 2 days later, on June 29th, the team turned their attention to asteroid 2024 MK, which made a much closer approach to Earth, passing at a distance of only 184,000 miles, 295,000 kilometers, a mere 3/4 of the distance between the Moon and Earth. This asteroid, measuring about 500 feet, 150 meters in width, presented a striking contrast to 2011 UL21 with its elongated angular shape and distinctive surface features. The radar images captured by the Goldstone Solar System radar revealed prominent flat and rounded regions, along with surface concavities, ridges, and boulders as large as 30 feet, 10 meters across. These details offer invaluable clues about the asteroid's structure and composition. Voyager 1's remarkable return to science. In another monumental achievement, NASA's Voyager 1 spacecraft, which is currently the farthest human-made object from Earth, has resumed its steady stream of scientific data after a 7-month hiatus caused by a computer glitch. This glitch had temporarily sidelined the historic mission, leaving the spacecraft incommunicado and sending back only an indecipherable repeating pattern of code from its location billions of miles away. Voyager 1, which stopped communicating coherently with mission control in November 2023 appeared to be trapped in a Groundhog Day scenario. The spacecraft's Flight Data Systems Telemetry Modulation Unit was sending back this mysterious pattern, leaving the mission team puzzled and concerned. However, through a combination of creative problem-solving and determination, the Voyager mission team managed to restore communication with the spacecraft in April. Engineering data soon began streaming back to mission control, providing vital information about the spacecraft's health and operational status. However, the road to fully restoring Voyager 1's capabilities was not straightforward. Data from the spacecraft's 4 science instruments, which are crucial for studying plasma waves, magnetic fields, and particles in interstellar space, remained elusive. This information is essential for understanding how these particles and fields evolve as the spacecraft continues its journey beyond the solar system. On May 19th, the Voyager team sent a command to the spacecraft to resume transmitting science data. While 2 of the instruments responded promptly, the other 2 required more time and careful recalibration to begin functioning correctly. By June 13th, NASA confirmed that all 4 instruments were once again operational, beaming back usable scientific data. The Voyager 1 spacecraft's flight data system plays a critical role in its mission, collecting information from the science instruments and packaging it with engineering data that reflects the probe's overall status. This data is then transmitted to Earth in the form of binary code, a series of 1s and 0s. Decoding this garbled code took time, but the Voyager team eventually identified the cause of the issue. Approximately 3% of the flight data system's memory had been corrupted. The problem was traced back to a single chip responsible for storing part of the system's memory, including some of the spacecraft's software code. The loss of data on this chip rendered both science and engineering data unusable. With no way to repair the chip, the team devised a workaround by relocating the affected code to other parts of the system's memory. Although they couldn't find a single location large enough to hold all the code, they ingeniously divided it into sections and stored it across different areas within the flight data system. Even with these fixes, minor adjustments are still necessary to manage the residual effects of the initial problem. Despite these challenges, Voyager 1 has returned to doing what it does best: exploring uncharted cosmic territory and providing humanity with unprecedented insights into the vastness of space. Currently, the spacecraft is about 15 billion miles, 24 billion kilometers from Earth, while its twin, Voyager 2, has traveled over 12 billion miles, 20 billion kilometers from home. Launched weeks apart in 1977, the twin probes initially conducted flybys of Jupiter, Saturn, Uranus, and Neptune before embarking on their extended missions, which have now spanned 46 years. Both Voyager 1 and Voyager 2 are now in interstellar space, the only spacecraft to operate beyond the heliosphere, the Sun's protective bubble of magnetic fields and particles that stretches far beyond Pluto's orbit. The Voyager probes continue their lonely journeys, traveling in opposite directions into the unknown. The information gathered by these intrepid explorers is invaluable. It is helping scientists understand the comet-like shape of the heliosphere and how it shields Earth from the potentially harmful effects of energized particles and radiation in interstellar space. Over the years, the spacecraft have faced numerous challenges, including unexpected issues and communication dropouts. One notable incident occurred in August 2023, when the Voyager 2 team used a long-shot shout technique to restore communication with the spacecraft after a command inadvertently reoriented its antenna away from Earth. Despite the uncertainties and challenges, the Voyagers continue to astonish and inspire. As Suzanne Dodd, Voyager's project manager at JPL, remarked in April, "We never know for sure what's going to happen with the Voyagers, but it constantly amazes me when they just keep going." As we continue to push the boundaries of space exploration, these discoveries remind us of the vastness and mystery that still lie ahead, from capturing detailed images of asteroids to restoring communication with a spacecraft billions of miles away. NASA's work not only advances our scientific knowledge, but also fuels our curiosity about the universe. If you enjoyed this dive into the latest space milestones, don't forget to like, share, and subscribe for more updates on the incredible journey of discovery beyond our planet. Thanks for watching, and until next time, keep looking up.